Manganese, group 7. 7 electrons in outer shell, 4s2, 3d5. It is possible to remove all 7 electrons to get oxidation number +7. Oxidation number 5 and 6 exist, but they are not common. Relatively stable is oxidation number +4, but the most common is +2, which will give you electron configuration of 3d5. All 5 electrons are sitting at separate d orbitals, and there are several minerals that can be sources of manganese. Most common are pyrolusite, manganese dioxide, black rock. It can be Mn3O4, which means it's mixed valency 2 and 3, and manganese 2 carbonate, MnCO3, like many manganese 2 salts. It's pale pinkish. Manganese oxide can react with active metals such as aluminum to produce elemental metal. Manganese oxides in a mixture of iron oxides, very often it's natural mixture in a rock, react with carbon, usually coke, to make ferromanganese and carbon monoxide. Ferromanganese contains some carbon and used as alloying material in steel production. It is added to iron melt to get necessary amount of manganese in steel. Physical properties of steel alloys changes with concentration of manganese. Pure manganese is often produced by electrolysis of its sulfate. Starting with manganese 7, no electrons left. It's tetrahedral compound, stable on air as potassium salt, stable in solution with characteristic pinkish purple color. Very strong oxidizer, can oxidize hydrogen peroxide, Fe2 plus ions, can oxidize most of organic compounds to CO2 and H2O in acidic medium. All oxidation results in Mn2 plus ions in water. When you reduce manganese 7 in alkaline solution, you have manganate 6, still manganate ion, with one single d electron left. That's why bright green color. Manganese 7 makes manganese oxide Mn2O7, which relatively easily decomposes into MnO2 and molecular oxygen. This is per diagram of manganese. You can see that in common area of stability you have manganese 4 and manganese 2. It takes very negative potential to reduce manganese to metal. Also, there is area of stable manganese 3. Manganese dioxide reacts with acid to make MnCl2, salt of manganese 2 plus ion, chlorine gas, and water. Same reaction with sulfuric acid yields oxygen gas. It is a working material in a usual zinc battery or alkaline battery, which is based on older Leclanché cell from 1866. MnO2 reacts with ammonium chloride, making manganese 3 oxide. Similar reaction in alkaline battery results in the same compound, but zinc will make zinc hydroxide. Again, when MnO2 reacts with hydrochloric acid, you have manganese 2 compounds, and they have 3d5 electron configuration. They all are almost colorless, barely visible pinkish color in solid, and no visible color in diluted solutions. Several salts are shown here.